All right, today we have count nodes equal to average of subtree. Given the root of binary tree, return the number of nodes where the value of the node is equal to average of the value if in its subtree. The average of the element sum of the n element divided by n rounded down to the nearest integer. Subtree is a root of tree consisting of root and all of its descendants. So in this case, 8, no, right? How many do we have here? 5. Wow, how it's right. For the first node value is 4. The average subtree is 4 plus 8 plus 5 plus 0 plus 1, 6 divided by 6. Okay, is 4, which is correct. For the node with value of 5, the average of 3, 5 plus 6. Oh, so it's including. Uh, for the node value 3, the average of 3, 0. For the node value 1, the average of 3 is 1. 6 is value is 6. What? Okay. So if we have a node X, we say if X value equal um, plus all nodes left nodes. Yeah, so we can we can do DFS and go all the way down until we found leaf, right? If we found leaf, so for example, I can say in the first function which accept root, which accept node, I can say if node left, if node left, and node and right, and let's say count right equals 0. Right, I can tell that if there is no if and value equal, we have a 6, right? Nothing in here. We have a 0. 6 divided by 1. It's average no matter what. So 1 is 1. So it will be 1, 2, 3, 4, 5, 6. 5. 5 because this doesn't work. 5, it's 2, 5 plus 6, 11 by 2, it's 5. Okay, so we adding, because if we have a just one node, right? And we return and val. Else we add if dfs if and val. Yeah, I have to keep like I have to keep amount of nodes as well. So I jumped into coding which is not right without knowing like how I'm gonna solve it like exactly. So we will create a recursive function called dfs which accept node and it accept amount, or it will return amount. And then I will call dfs and with root, right? And inside dfs we'll say if leaf, if node and we define counter variable count equals 0. And then if I also have to print Subtree somehow, or like, okay, if leaf we add count 1, right? Otherwise, what we call, and we return and value. Otherwise, we we this one if DFS of if and val equal DFS and left plus DFS and right. But how? Maybe I will pass count of nodes, like count, and I will call with 0, and as I go deeper I increase count. Like this, right? But how about if I call it with um, empty node? What does this mean? I probably shouldn't call it. Oh, for example, here, right? Here is 5 and empty node. So I shouldn't increase counter. I just return. Um, I can say if node nodes, then return what? What shall I return? 0 maybe. Okay, how it will work in this case? So first we call with 4, and we call VFS 8, and we call 5. We add 0, we add 1 and 1. But first we call left, so we call 8, 1. Then we go here and we go call with 0, 2, 1 and 2. It's leaf, so we return 0 back. We increase counter, right? We return counter, we increase counter by 1, we increase by counter by 2, And what we have n val equal n val plus, we have to add it, and here is 0, 1, 2, 0, 1, counter is 1, so we add 2 and 2, and counter is 1. But how Subtree knows? I should return counter back somehow. Because how 8 will, node 8 will know that it has 2? Um, yeah, it's hard for me to say how it will work. Let's try to implement this and see what it will print, because I don't know, it's hard for me to say. What is sleeve? Depth is sleeve node return and left and not and left and not and right. And we'll try to call DFS as maybe return count, or like self count. Right. Oh yeah. Function. Yep. Yes. because I believe at some point, so we have 4801, and then we return and so unknown type is returned from DFS. I believe. What I'm missing here is DFS. Because here I have to return something. What I have to return? If I return back something 480188 return, I return some and count. Maybe let's say I will return n-val n1, right? And here I can say that I can do left value, left sum, and left count equal DFS right sum right count equal right. Then here I check if this is right sum plus left sum, and I do right count plus left count, and I return tuple with left sum plus right sum, and left count plus right count, right? And here I can tell equal and root count root sum. Let's call it root count root sum. No, first is always sum. What is this? And then if root value equal root value plus root sum plus divided by root count, then we add count as well here. I'm not sure if it's in there, but let's see. Okay, maybe I will return 0, 0. Why it's not packing, unpacking? Cannot unpack. Because I'm calling. I'm at position 1 and it's 1. And now I have to return back. I think somewhere is a mistake and it's here. Alright, non-type. I know why it's because it should be +1, right? No, maybe no. Oh, this one is working with a 1, yeah. Okay, so 6 is 2. So we go 4, 8. Yeah, we have to print. I'm not sure. See, it's only returning, it's only adding when left is when, let's print this guys. So I want to print left sum, left count, right sum, right count. Syntax. I can't print like this. So we don't have to print if we are going into lifts, right? Maybe print, let's print which leaf we are. At the end, we have left count 0, left sum 0, perfect, left count 1, right sum 1, right count 1. Obviously counter is 0, right? But for example for 5 we have left count, left sum 0, left count 0, right sum 6, right count 1, and we have 5 plus 6 divided by right count 1. Yeah, we have to add plus 1 here. And plus 1 here, maybe. Yes. Let's submit it. Almost there. Come on. Oh, wrong answer. Okay. Wrong answer for this one. No. So we have 1, 3. Use this case. 1, 3, 1, 3. Okay. So that's funny. So we have 1, 3, 1, 3, 1, 3, 1, 3. Right. And we have 3 plus 1. Together they are not. Because it's 2.5. Oh, do I have to? Okay, so how let's say close and rounded. Python rounding round function number digits optional default. Do I have to do Do I have to do like this? Like this. Nah, doesn't work. Oh, let's print that thing without rounding and see the beauty. Eight three zero 5.561. Okay. 4 275 261. 275 is a 3. For the value of 4 5 0 1 6, it's understandable, but for 4 plus 8 plus 5 plus 0 plus 1 plus 6 and divided by 6. Let's print this beauty here. 4.6.6666, which is not 4. Okay, I'm adding 85434 plus 85016. Mm. All right. Yeah, I think I will take a break and continue in part 2. Thank you for watching and continue finding problem in next part. Thanks.